In this video, we are going to go over stoichiometry excess reactant calculations. By the end of the video, we should be able to calculate the limiting reactant using other mole relationships and calculate how much the excess reactant reacts and how much is left over. The first example asks how many moles of iron oxide can be produced from the reaction of 13.17 moles of iron with 18.19 moles of oxygen. First, we're going to do the word equation and then bring down the formula equation. Iron is not diatomic, oxygen is, and iron oxide is ionic. So you're going to do the charge thing, cross it down, and you have your subscripts. Then we're going to balance the equation. And after that, we're going to grab our two knowns and our unknowns. So our first known is 13.17 moles of iron, and our second known is 18.19 moles of oxygen. The unknowns will be the same. They will both be how many moles of iron oxide. Then we're going to just do the simple mole to mole calculation. So we're going to bring down our first known and then convert the moles of known to the moles of unknown, and then we will actually be at the end of our calculation. We're going to do the same thing for the second known, convert moles of known to moles of unknown. We're going to grab the mole to mole ratio numbers from the coefficients from the balanced chemical equation. And now we're just going to calculate them to see which one will be the limiting reactant and which one will be in excess. The one that is the limiting reactant will be the one that theoretically produces the least amount. In this case, it's iron. The least amount produced, or the amount that will actually be produced, will be 6.585. Okay, now that we have reviewed limiting reactant calculations, let's look at an excess reactant calculation. Basically, they're the exact same thing, except we have a couple more steps added onto it. The first question says what mass of cobalt chloride is formed from the reaction of this many atoms of cobalt with 57.92 liters of chlorine gas at STP. And it asks us how much excess reactant reacts and how much is left over. So the steps are the same at first. What we're going to do is write both of our knowns, and the unknown will remain the same, just like in limiting reactant problems. So the first known is the atoms of cobalt, the second known is the liters of chlorine gas, and the unknowns will be grams of cobalt chloride. Next, we'll bring our known down, cancel out our known, convert it to moles of known, then convert to moles of unknown, and then convert to whatever unit of known that we need. In this case, it will be grams of cobalt chloride. We'll grab the numbers we need for the mole to mole ratio from the coefficients of the balanced chemical reaction. Then we need to add cobalt and chlorine atom molar masses to find out the molecular mass of cobalt chloride. Next, we're going to do the second reactant. We're going to bring the known down, convert the known units of liters to moles. Then we can convert moles of known to moles of unknown and convert moles of unknown to the unit we want, which is grams, and we can reuse the molar mass that we calculated earlier. Then we grab the coefficient numbers from the balanced chemical equation, calculate both equations, find out which one is lower. That is our limiting reactant, and then we're going to do something with that. Okay, and it looks like cobalt is going to be our limiting reactant, and the maximum that can be made of cobalt chloride is 95.50 grams. And the excess reactant is chloride. So now what we're going to do is find out how much excess we have of chloride gas. So the first step to do is write our known and unknown. So the known will be our known of the limiting reactant, and the unknown will be the excess reactant. We're going to treat this problem just like the others. We're going to bring our known down, convert our units of known to moles of known, do a mole to mole ratio to get the moles of unknown. Then we convert our moles of unknown to whatever unit, in this case it's liters of unknown, and then we calculate it. And then this will be how much of the excess reactant actually reacted. Then we're going to have to do a simple subtraction problem to find out how much is left over. So what we just calculated is how much chlorine gas reacted in this reaction. And then what we're going to calculate next is simply how much was left over. So this is a simple subtraction problem of the initial amount we started out with, which was 57.92 liters of chlorine gas. And then what reacted was 19.41. So we're just going to take 57.92 liters. You can't see, I'm sorry, but minus 19.41. And then whatever that answer is, that's how much was left over. That's how much chlorine gas was left over. I'm about to show you. Sorry. Anyways, hope that was helpful.